Now students, application of trigonometry. Now introduction part. The height of the length of an object or the distance between the two distant objects determined with the help of trigonometric ratios. Trigonometry is useful to astronomers, navigators, architects and surveyors in solving problems related to heights and distances. We have already studied in social studies that the highest mountain peak in the world is Mount Everest and its height is 8,848. So like this, we have also seen Kuntala waterfall in Hyderabad districts, in the highest natural waterfall in Telangana. Its height is 147 feet. So how are these heights measured? Can you measure the height of your school building, the tallest tree in our all around our school? So to understand these examples, we have to take an example, some small story. Vijaya wants to find the height of the palm tree. She's tried to locate the top of the point of the tree. She also imagines a line joining the topmost point and her eye. So this line is called line of sight, as we all know that one. She also imagines a horizontal line from her eye to the tree. Here, the line of sight, horizontal line, and the tree form a right angle triangle. So to find the height of the tree, she needs to find a side of an angle in this triangle. So now, in this way, we can understand the sum. And next, but if we need to find out such heights and distances, trigonometry. So actually trigonometry is useful to the astronomers, navigators, architects and surveyors in solving problems related to heights and distances. Here we also use the Pythagoras theorem. In a right angled triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. In triangle ABC, if B is equal to 90 degrees, AC square is equal to AB square plus BC square. The next. So already we discussed the line of sight. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. So see this here, eye and object. The distance between or the line joining between the eye and object is line of sight. And the angle of elevation definition. The line of sight above the horizontal line and the angle between the line of sight and the horizontal line is called the angle of elevation. So these definitions is very important for exam point of view. They will ask what is the angle of elevation. Then what you can say, the line of sight above the horizontal line and the angle between the line of sight and the horizontal line is called the angle of elevation. Okay, and you must draw this figure also for good impression. The next important points on angle of elevation. If the angle of observer moves towards the perpendicular line, that is tower or building, then the angle of elevation increases. And if the observer moves away from the perpendicular line, that is tower or building, then the angle of elevation decreases. This is a very most important point. So keep concentrate on that point, children. And the second one, if the height of the tower is doubled and the distance between the observer and the foot of the tower is doubled, then the angle of elevation remains the same. Here only the sides are changed, but the angle of elevation remains same. And third point, the angle of elevation of sun above a tower decreases, then the length of the shadow of the tower increases. As we all know, as the sun setting on west side, then you can observe our shadow or any object shadow easily increases. Next. angle of depression. In the figure, see that AB is a pole and B is the position of observation, and point C is to be observed from B. Then the observer must be see down from the horizontal line of sight. Then the line of sight will be downwards, and the angle so formed is the angle of depression. You can see this one. You can see this line, a line of sight. The observer is on top of the object. Then here, this is the horizontal line, as you know, which is drawn from the line our eye, okay, which is imaginary line. Now again, here you observe, then the line of sight will be downwards, and the angle is so formed called a angle of depression. Okay, so very important definition. Okay, now once again see here, the angle of depression is in the figure. AB is a pole and B is the position of observation, and the point is to be observed from B. Okay, then the observer must see down from the horizontal line of sight. Then the line of sight will be downwards, and the angle so formed is called angle of depression. And here also some important points. Notes, you just remember these points. The angle of elevation of point P as seen from point O is always equal to the angle of depression of O is seen from P. Now, as we all know the way, here the horizontal line and the line of sight and AC line, the foot of perpendicular of that object and the observer, the AC line and horizontal line, these two are parallel to each other, and this line of sight is act as a transversal. So the angles of these angles are of alternate. So alternate angles are equal, as we know, that we discussed here. Next, angle of elevation and angle of depression are always acute angles. Next, now here you observe the one figure. Already I discussed this figure, that Vijaya observes the top of the tree and with an angle of theta. So he stands away from the tall tree. So here the line joining of the eye to the tree is taken as an horizontal line, and the eye to the top of the tree is taken as line of sight. So here the angle is known as angle of elevation. Okay. Next, here also one more example. One girl observes a bore point which is down. So he is standing on the top of her school or a building, and she wants to find the distance of the bore well from the building on which she is standing. So we have to observe the base of the bore well. So then the line of sight from the her eye to the base of the bore well is below the horizontal line from her eye. So the angle between the line of sight and horizontal line is called as a angle of depression. So once again I discussed these two figures, which are very important for an exam point of view. They may ask definitions for 1 mark or 2 marks. Now, to solve the sums, we must draw the figures. So to draw the figures, we have to remember some points. Okay, so the points are: first one, all the objects such as towers, trees, buildings, ships, mountains, etc. shall be considered as linear for mathematical convenience. So no need to draw the actual figures of towers, trees and buildings or ships, mountains. So we have to draw in place of those simply one perpendicular line which is exactly gives us the height. And next, the second point, the angle of elevation or angle of depression is considered with the reference to the horizontal line. Definitely you should draw the horizontal line from our observer point. And the height of the observer is neglected if it is not given in the problem. If he is given, we have to consider the his height. So when we try to find the heights and distances at an angle of elevation or depression, we need to visualize geometrically. To find the heights and distances, we need to draw the figures, and with the help of those figures, we can solve the problems. That means we must have some visualization and some of the imagination power to draw the exact figure to solve these type of sums. So based on these, they will ask the 2 marks question compulsory in exam point of view. They will give the one type of question and they will ask to draw the figure, only figure, and give the description. Okay. Now one sum here. An electrician wants to repair an electric connection on a pole to height 9 meters. He needs to reach 1.8 meters below the top of the pole to do repair work. What should be the length of the ladder which he should use when he climbs at an angle of 60 degrees with the ground? What will be the distance between the foot of the ladder and foot of the pole? So important for them. They may ask for 4 marks. If they are only the sum for drawing the diagram, it is for 2 marks. So keep concentrate on this sum. Now here I am taking one virtual diagram. So that electrician climb a ladder which makes an angle 60 degrees with the horizontal line or with the base, which is the line joining of the foot of the electric pole and the foot of the ladder. So he climbed somewhere and he has to select the repairing point which is below the 1.8 meter. Okay, below the 1.8 meter from the height. So actually the height of the pole is 9 meters. So but he is worked at a height of 7.2 meters and below the 1.8 meters. Okay, now see this figure. First I draw the perpendicular line and then base and then this slant line which makes an angle 60 degrees with the base. Okay, now here AB gives us 7.2 meters and BD gives us 1.8 meters. And here they assumed AC, that is the distance between the foot of the electric pole and foot of the ladder. The angle between them is simply here he has given as 60 degrees. Okay. Now see the solving. The height of the electric pole AD is 9 meters, in which the repair will be held on 1.8 meter below the top of the pole. Here AB is 7.2 meters, angle ACB is 60 degrees, BC equal to A meter, the length of the ladder. In the right angle triangle BAC, we have the tan 60. That is equal to opposite side by adjacent side, that is AB by AC. But we have here tan 60 is equal to root 3. That is equal to 7.2 divided by x. Now here on cross multiplication we get actually x is equal to 7.2 into 1 by root 3. So on again root 3 rationalization, we can write into root 3 by root 3 Actually, the step is here what he did. And again, x is equal to 7.2 into root 3 by 3. Why? Because root 3 into root 3 is 3. Now 3 ones are 3 is 2.40. We get 2.4 into 1.732. Then on multiplication we get 4.1568. That is the distance between the foot of the pole to the foot of the ladder. Next, in triangle ABC, sine 60 is root 3 by 2 is equal to 7.2 by A. AB value we have already 7.2. AC we don't know, that is A. A is equal to 7.2 into 2 by root 3. Again root 3 is rationalized into root 3 by root 3. A is equal to 14.4 into root 3 by 3. So by substitution, root 3 value 1.732, we get A is equal to 8.3136 meters. So the distance between the foot of the ladder and foot of the pole, x is equal to 4.1568 meters. The length of the ladder, A is equal to 8.3136. This is a very important sum. To practice well. We will discuss another sums in the next video. Thank you.